you for the introduction. Hello, thanks for coming here, and I hope we are going to have 45 minutes of pure fun and pure functional programming. So before we begin, just a quick one because this was covered already. This talk is for you if you want to learn how your language tooling works under the hood in general, like for any kind of language, or if you want to build tooling for your own language of any kind, or if you just want to have fun. So we will start with a story. Meet Jane. Jane is a software engineer in a team, which is the team is tasked with building a language. It's going to be a small DSL meant to be used in an existing application which runs on the JVM. It's a Scala application. No surprise, functional programming. But because it's a JVM-based language, the compiler or any kind of tools, any kind of interpreter, whatever is going to be embedded in the app, also needs to use that language, or at least something that compiles to JVM bytecode and you can interoperate with it. So that's not a huge issue. There are tools for building anything in Scala or on the JVM. So 2 or 3 weeks later, the compiler is done and embedded in the application, and Jane's life is good. Until she starts getting users, and they want something called editor support. And what they really want is a smooth editing experience. They want some kind of analysis from the tool, from the editor. They want to see the errors that they have. They want to be able to navigate around the code base or the script base. They want to be able to refactor the code with things like renaming or removing unused variables and statements and many other things. And they also want some help when just writing the code just to autocomplete some of that code. So there are a couple options here. First of all, Jane can write a special editor just for this language, or she can integrate with an existing editor. And the major flaws of writing a special editor is that it's a lot of work, especially front-end work, in my opinion at least, for something that may not pay off in the longer run. If it's a small language, just like a DSL embedded in an app, then chances are you don't need to do all that extra work just for this language. You don't want to build like a new editor for that. And also, that would not be the best experience for the users because they would have to learn a new editor, even if they already are familiar with some other ones, just to work with your DSL. But if you do decide to integrate with an existing editor, you have to choose which editors you want to support. And here we have a hint from the users. They are asking for IntelliJ support. I don't know what kind of application this is, like what app could embed a DSL in which the users also know IntelliJ, but let's just assume this is the case. So the good thing about IntelliJ is that it's based on Java, so it runs on the JVM. And that means that we can easily integrate the tools that are already there, the compiler or interpreter, with this editor. We just have to learn the IntelliJ extension API, which has some intricate complications to it. But sometimes, this isn't rocket science. You can learn it, and sometime later, the extension is up and running, and Jane's life is good. Until she gets more users, and they are now asking for VS Code support. Or NeoVim, insert your editor of choice. So the problem with this editor or other editors is that it doesn't run on the JVM. It runs on some other platform. In this case, it's Node.js. And there is no good story for interop between Node.js and Java or the JVM. Whatever you do, it's going to be like a trade-off of tooling and complication and pain. And on top of that, you have another extension API to learn because the way that plugins or extensions work in IntelliJ is different to how it works in things like VS Code. So that's another layer of complication. So here are our options, like the sane ones. So, well, rewriting the compiler maybe is not the most sane option, but this can happen sometimes. There are people who would do that, and it may be a sensible choice if it's simple enough. You can also try to transpile the tooling that you already have for the JVM. And in a language like Scala, this is actually possible. You can compile Scala to JavaScript, which works very well in environments like Node.js and including VS Code. I have done that before. Or you can shell out, you can start a separate process with the JVM and somehow communicate with that process from Node, which is also a possibility. And only one of these really scales if more editors are needed. Because if you have another editor in the future, maybe it's not Node-based, maybe you cannot compile to that language, maybe it's something like Lisp or Lua, then you're in trouble. You wouldn't be able to reuse that Node transpiler or whatever. So we will start a separate process. Jane decides to shell out. And this is going to be like a client-server architecture. The editor extension, in this case, something like VS Code or something else, we will call this the language frontend. It will start a server in a separate process. The server, which we can call the compilation server or the language backend, will run on the JVM, because that's what the tooling exists in. And the editor extension will send remote procedure calls to the server. The server will do some kind of analysis and return results whenever necessary. And the editor will also be responsible for closing the server when it no longer needs it, when it's just being closed just to clean up resources. So yeah, again, this is just going to be like two separate things talking to each other on using some kind of protocol. I keep forgetting how this. The client will have a couple responsibilities. It will, first it needs to trigger somehow these calls to the server. So it will listen to actions from the users. Things like requesting completions or hovering with the mouse on something, if your editor supports even using the mouse. Clicks, keyboard shortcuts, all of that. When something happens that the editor decides that it doesn't have enough information for, it will ask the server for that information. It will provide some parameters like where the cursor is in the file, which file it is, maybe which directories are the workspace roots in your project. Things like this will go to the server. And when we get a response from the server, the client or the front end will look at this response and apply appropriate actions. For example, in completions, if it gets like a list of possible endings to the current statement, it will show like a drop down to the user. And the server, when it gets these parameters that we talked about, it will use them to load the file from disk or from the editor buffer. We will talk about that later. And it will parse the file, it will analyze it, and it will spit out some kind of useful response, which the client can then use to its advantage. Of course, all of this needs some kind of common interface, some kind of common protocol on a high level. So basically like methods that can be executed on this communication. And this also needs a name, a really catchy name. So Jane wants to call it Language Server Protocol, but she Googled that and it already exists. So it's going to be called Language Backend Protocol. And for simplicity, it's going to use the stack that everyone is mostly familiar with, the HTTP protocol over TCP. And because it all runs on the same machine, it can use just local TCP. It's going to be very fast. So Jane implements the changes because she had an IntelliJ plugin. Now she's going to move all the language features to the language backend, implement a VS Code extension which will use a client to proxy to that backend, and she will adapt the IntelliJ extension to also use that backend, but like internally. That actually doesn't need a server. It can all happen in memory because it's the same runtime, the JVM. And Jane's life is good. Until she gets a DM from a coworker, whose name is Trish. And Trish has a similar issue. Her team is also maintaining their own language, and they also got asked to support multiple editors. And she's thinking of doing something similar to what Jane did, something like a language backend or like a compilation server in order to feed back like analysis results to the editor, the editors, plural. And she's asking Jane for guidance because she's done this before. And Jane is thinking, hey, the front-end knows almost nothing about the language. It only knows like what extension the file uses, like is it .txt, .scala, or .hs. And it knows how to launch the server. Other than that, it knows nothing about like the structure of the language, the syntax, the dependencies, build tool, whatever. So there's no reason why the extensions, the front ends, should be like hard-coded to a single language. So she decides to let Trish sort of join the effort, and they will use together the same kind of protocol, which will allow the other team to reuse the same kind of front-end tooling. The existing editors will just work with some configuration, and they will just speak the same language. It should all work. But there's one problem with this. Trish develops a language that is more like a general purpose program language, and it has things like functions and modules and things like that. And that needs some more features, some features which cannot really make sense in the language that Jane had. For example, call hierarchy. The previous language that we looked at, it didn't have function calls. It cannot have a call hierarchy. So Trish needs that, and Jane cannot implement that. So that is a general problem. There are so many more features that make sense in some languages and not in others. And for this reason, they decide to make server features optional. So when the server starts, it will describe what it can do to the client, and the client will be able to take some actions based on this. For example, in Jane's language, which does not support a call hierarchy, the extension will just not show the option to open the call hierarchy. So the server will describe what it can do. It's going to be a new method in the protocol called initialize, which will be called by the client when the server launches. So the client starts the server and then immediately follows up with a call. The server then says which features it supports, and the client looks at that and just hides the ones that are not supported. Another benefit of this is that you can add new methods to the protocol, and the clients and backends, the clients and servers, the frontends and backends, can support these features at their own pace. So if both sides implement the feature, then it can be used. So all this work gets done. The servers are updated to use the same protocol, to declare their capabilities. And the clients, the extensions in the editors are updated to hide the features not handled by the backend. And also, we talked about this briefly, but the clients also need to get the ability to sort of launch different backends depending on the file type, so that also gets implemented with some configuration mechanism. And Jane's life is good, until she gets a user complaint. Some actions are visibly slow. Now, this is a general problem that we probably cannot handle in a general way, but what we can do is give users some feedback so that they know that they should wait just a little bit more, or maybe that we had some sort of error, or we are waiting for the network to come back up. So we want some sort of way to give users feedback in the middle of an action, because the action is just slow. And the current problem with this is that only the client, only the editor can initialize calls. So the server cannot just say I will return a response right now, and then later another one. That's not possible in the current design, because it's just HTTP client server. That's just a flaw in the protocol. So Jane decides to add feedback to this protocol, and in order for this to make sense, that cannot really be HTTP, at least not HTTP 1.1 with no WebSockets. So some kind of bi-directional communication needs to be introduced. And Jane decides to use JSON RPC. It's a very simple protocol for exchanging requests between two servers, two devices or two processes, and they can all use the same. Both of them can use the same channel so that they can send requests to each other. The client and the server can ask each other questions. And this can use any kind of transport protocol. It can all happen on standard input and output, or TCP or WebSockets. It doesn't matter. We're going to assume standard input output because it's the easiest to implement. So a new API will be created. Previously, we had this language backend API with some methods. Now we'll also have a language frontend, which will have these things like feedback or maybe opening a dialog, things like this. And the server will use this kind of this protocol, this API, to talk to the client. And for this, we need to update this initialize request. If you remember, this is the one that described the server capabilities. Now, because not every client will have the same capabilities either, we will allow the clients to also advertise what they can do. And that's going to be the input to this initialize operation. And based on this, the servers will adjust their behavior. For example, if the if the client has the ability to show a message, the server will show a message when it starts, just like a hello world or something like this. It's actually a common practice that the server says welcome to this language server. I mean, in Jane's world, of course, this isn't real. So Jane gets to work. She updates the editor extensions, and the server and the extensions also add support for this server-to-client communication. And now the language backends can provide estimations. They can show notifications. They can print something to the logs of the client so that the user can see it. And Jane's life is good. Until she gets another user complaint. The editors are often breaking. What this really means, because you know how user feedback can get very, very vague, right? So after some investigation, it turns out that the problem is that the users cannot see any useful output. They cannot get any correct analysis unless they save the file. This is because in our initial definition of the protocol, the language backend, basically all the operations were based on file paths. So any kind of operation gets a position of the cursor and the file name or path or URI. And the editors don't constantly keep saving the file to disk whenever you do a keystroke. They will keep that in memory and they will not send it to you. Like in this current design, they don't send it to you. So we need some kind of way for the protocol to account for files that are not saved. How do we do that? Well, there are many ways, again. We could pass the file text in every request, which is going to be very wasteful and non-incremental. You cannot easily compare what changed between two requests to your server. We could ask the client, so in this new language frontend protocol, the server could, when it wants to do completions on the file, it could ask, hey, have you made any changes to this file? The client could respond, but this is again wasteful and non-incremental. We cannot get something like the client would tell you that one line has changed, and the server would only have to recompile one file with one line. And also, if there are many unsaved files, it will be very difficult to keep track of all of them from the server. It would have to understand which files it should ask for, and that's just a lot of trouble. So Jane has another idea. She will introduce methods to the protocol which are going to be used for syncing documents. So when the file changes, the client or the frontend will send an update of that file to the server. And depending on the server capabilities, this can be a full file, this file is now this. If you know the previous version, you can do whatever you want with it, but this is the new state. Or it can be incremental. It can be just this range of text has changed to this range of text. And the server will use this information to keep this kind of data in memory, like a cache. And when the file is closed or saved, closing a file in most editors would involve a save. But regardless, the extension will tell the server that it can free up this cache for this particular file. And the server can now operate on just the file from the local storage, from the disk. As an additional benefit, because we get notified about all changes, we can pre-compute analysis results. The server can sort of start doing the work before the user even asks for it. So let's say you have a completion request, you can have a response ready before the user even asks, because the file, all the changes to the files, you would already know about, and you can compute that before the request. A very useful and common case of doing something like this is when you change a file and it breaks compilation in another file. You want to know about that before you go to the other file. So that works, for example, in the Scala language server. In Jane's world, of course, this isn't real. And yeah, so this is like caching and also early, like ahead of time computation. Again, this is all implemented. The servers will listen to these events and keep an in-memory file cache. And the editor extensions will send these updates when necessary. And Jane's life is good. All the features now work. Until she decides to give back to the community. Because why keep this to ourselves? This is very useful. So Jane wants to open source this protocol because the idea is generic enough. It can be applied to any kind of programming language, virtually any kind of text-based programming language in existence, or even not a programming language. It could be HTML. Nobody's going to argue that HTML is a language? Okay. Disclaimer, I'm not making an opinion here. It's just a fact. But yeah, another benefit of, well, first of all, you can support many more languages if the community decides to implement more servers. You can have support from more editors if the community implements that. And you can also have more features in the protocol itself if someone suggests a good one. So it's a win-win. So Jane goes back in time to around 2015 and joins Microsoft to work on the language server protocol because that's what happened. And now Jane's life is good. Jane will return. Just kidding. She's not. This is the end of the story. So in summary, not all of this was like what the real language server protocol looks like, but let's just look at the parts that do. The problem that LSP is supposed to solve is this multiplication of integrations. The more servers, the more languages and the more editors we have, you're just gonna have to implement each with each, and that doesn't scale. So instead we have just like a plus of this, so you support N editors, you support M languages, and you just add that. That's the amount of work that you have to do, because everything is using this common layer of the language server protocol. So the language server protocol was made by Microsoft together with Red Hat, I think, and some other companies. It's a common specifications for language features in editors and other tools. It's supported by most modern editors. And it is based on the communication is just JSON RPC with an extra mechanism for headers. That's like a detail. And yeah, both sides can talk to each other and send some requests. And the capability mechanism is also there. So when you start your server, you have to describe what you can do based on what the client can do. An example call, like a realistic one, is go to definition. This is from my toy language that I made for this talk. So when you click on inc Y in line 4, you want to you want your cursor to be moved to line 2. The way that this works in LSP is the client will send a text document / definition request. This will have a URI of the file and the position of your cursor. So in here we have line 3, character 5. I actually can see that. Okay, character 5. The server will take that and return. That's here. The server will analyze the file, parse it, do whatever it needs to do, and return a response. The definition is in the same file, so we still need to have a URI for that because it could be a different file. It's in the same file, and it is a range, so between two positions in the file, right here in line 2. The numbers here are 0 index, so you need to translate between the LSP and the real file editor. Because for some reason we edit files in lines starting from 1. So now let's talk about, I just want to talk about some challenges that I faced when working with the LSP. I have worked on 4 language servers. One of them I made myself and contributed to 2 of them, and the 4th one is just this toy one. So a major issue in any kind of language-related tooling is going to be parsing. At least if you want to do it right, it's going to be a problem. So what parsing is just the process of making some text structured. So going from just a string of text to something like a tree of the syntax. So in this case, we have just 2 statements, two operations in my file. And you can see that it's a relatively small input for a relatively large output. There's like a lot of stuff happening on the right side. So I'm turning the string of text into a source file, which has two operations, a let, which has a name, and it has a value. The value is a numeric literal. And we also have a show operation, which takes a list of parameters. And here there's just one parameter, and it is the variable x. Simple as that. But this isn't exactly everything we need to do, just getting this structure. You need to do parsing to do virtually anything with your language. Any kind of analysis is going to require this. But you also need to keep track of locations or ranges in the input, because you want to be able to, for example, navigate back to a definition or see what the symbol under the cursor is. So you need to keep these ranges, the line and column. So a more honest description of what parsing does is this. You need to keep not only the kind of thing that you're looking at, but also where it is in the source code, so that you can provide correct navigation, for example. And if you work on this, I really, really recommend having good tests from day one. Because the more rules you add to your language, the more you're gonna just bump into edge cases, and you're gonna possibly change something in an incompatible way. So the way I did this for another language, here's using this badlang, but it was actually another language, is I had sort of automated generated tests. I have a directory structure where there's like a directory per piece of syntax, and inside that there's a directory per test case. And then there's like an input file and an output, where the output is a sort of structured result of parsing that input. In this case, it's serialized.json because it needs to be some kind of serializable format, but you get the idea. And when I run these tests, I would see results. And if something fails, it is really useful to have a good diffing framework for the tests, so that you can see immediately what the problem is. Like here, I have an invalid offset in my file after parsing. And also, what is very useful, again, is to generate these outputs. This is sort of like a golden test. The first time you run a new test with no expected output, you can have the test harness generate what it would expect in the next runs. So then you can check that in. It has a downside because you are sort of trusting that it worked the first time, but the alternative is that you write all this JSON yourself. So it's up to you. And a really important and very difficult thing, much more difficult than testing, is making sure that the parser is failing gracefully. So even if your file doesn't parse as a fully correct file in the target language, you should still provide some kind of functionality, and your features in the extension should continue to work. And yeah, that is really hard. I cannot state this enough. One of the things you can use to make this easier is TreeSitter. It is a parser-generated tool. It generates parsers in C, but stay with me. It's fast, it's incremental, so when you have like a previously parsed version of the file, you can just say, this range has changed, and it will do a very quick turnaround of producing the next version of the whole parsed tree, which works nicely with the LSP if you have incremental changes enabled. And it handles errors gracefully. So even though the file, for example, here I have a JavaScript file with an incorrect number, even though it is invalid, it still gives me like a parsed tree. It's just that there's going to be an error node somewhere inside. And even though it's written, well, it generates code in C, you can compile this to WebAssembly for use in many other languages. And there are also bindings for Node and for Rust and other languages, but these ones are, I think, the top ones that are officially maintained. There are also downsides to using TreeSitter, but yeah, I'll let you discover these on your own. And there are also talks about that. Another source of great ideas for graceful parsing, this is a blog post for like 2018, and I just saw it like a week ago. It's about just the general idea, not any kind of library or tool, just make sure that you always parse to something. So even if the input is not correct, there should be a rule in your parser that just captures an incorrect input. And then you can pattern match on that, and you can still provide useful features even though the file isn't fully correct. Here's another challenge that I faced. Is maybe not that difficult as parsing, but it's still a bit complicated, so I wanted to cover that. Formatting. So basically pre-printing your code, going from like lots of white space, redundant white space or characters, to something concise and pretty. Yeah, that's what this is. And there are many ways to do this again. The main problem for me was keeping code comments. Because normally when you parse things, you sort of ignore comments, right? That's the whole idea. Like in the comment, you should just ignore whatever it says. But if you want to format your code, you don't want to remove comments. So you cannot just parse the file as you would normally for other features and sort of pre-print that. Because you will lose these comments. And it's not as simple as you think, not as easy. Because to this day, the DAL language server removes comments in working code. So there are basically like two main ways to do this. First of all, you can have comments as part of your parser and just print them back and then ignore them for anything else. Or you can not parse for formatting. You can just use a lexer or tokenizer and just parse in quotes, convert your text into a stream of tokens. So just like small pieces of syntax, keywords, and so on. And then work on that stream or list of tokens without this sort of tree-like structure. And this makes it apparently easier to print code with comments. I don't have a recommendation for any of this. These are just the ideas I would check. And there's plenty of documentation, well, plenty of prior work on this, and blog posts and so on. And I also recommend having tests for this from day one, because you're gonna have edge cases in this, in your formatting. Like maybe for empty objects, you don't want to include a new line. Maybe for empty comments, you want to remove them, and so on. There are many cases that you want to support, so for each one of them, I would recommend having a test. Speaking of tests, how do we test our server? Because there's a lot that can go wrong. No surprise, the test pyramid still applies even in this case. This is nothing special. We need unit tests, we need integration tests, and some kind of end-to-end testing. I would start with unit tests where you don't need to involve LSP. So things like just analyzing an AST, a syntax tree, the result of parsing, analyzing it to produce some results like completions. It's just like data in, data out, nothing magical, no state, no files, no effects. And in here, we just follow generally accepted industry practices. Then we have component testing. So this can include something like you have this string input. So this would also include the step of parsing, maybe. This might not even be a string. It might be like a URI. And you don't have to involve LSP in this stage either. You can still do this sort of in memory and with your own constructs of your language compiler. But you want to make sure that whatever this produces, like these components, can easily be converted to LSP or LSP types. And these work on a higher level, so you test like entire features. You don't want to have too many of these, but you still want to have them. Finally, integration testing. So now LSP is involved, and you have like a workspace, so you have actual files. You don't have to necessarily involve the JSON RPC protocol. This can still happen in memory, but you want to use real files just to check that you are correctly listening to these change events, that you are correctly dealing with URIs, that you are correctly reading files from the file system. And any kind of other state in the server, like precompiled results, would also be covered in here. This is not even the end, but there is end-to-end testing on the server only. No client, no front-end. You want to cover everything that the server is doing. So you want to launch the process as part of the test, launch a separate process, connect to it with an LSP client, send a request, and look at the response. This is already going to give you like a high degree of guarantee that things will work when the client connects, because you are like covering all the bases, and including the transport, including whether you redirect standard input-output right, because it's not trivial. And yeah, that's very good to have. But probably you just need like 1 or 2 of these tests for the entire server. And it's still not like a full end-to-end test because we haven't involved the client, but it's going to give you a high degree of confidence that things are working, and it's going to be a faster feedback loop than starting like a editor. Speaking of which, we can also end-to-end test with the editor, and in fact, this doesn't really test the server at all. Like, you don't have anything to do with the server in the test itself. Whether there is an LSP connection going on or not is really just an implementation detail. What you're testing is whether your extension works correctly. So you're using your editor's APIs to launch it, and then trigger some, like maybe you want to see completions at a given line. So then you're making assertions on these outputs, just like what was displayed to the user, right? So this is going to have to happen in the language of the editor, and again, this is basically a test of the extension, not the server. But it does cover that the client is able to launch the server, which is very important because it is part of the extension. And I think this is the last one, debugging. So any kind of issues that you face with writing a language server or any kind of other app, really, you want to first reproduce and minimize the issue as much as possible. If there's state involved, try to separate that state from the issue. Try to write a test so that you can get a fast feedback loop. When you eventually do fix the issue, you will immediately know about that. Try to eliminate like concurrency and so on, and non-determinism. And yeah, I really urge you to try and use your host language's debugging tools, because this is like a vastly underused feature of all of these. I see people not using a debugger more times than I see them using it, and it's really just a shame because these are really great tools and very useful. And also check Langoustine Tracer. Langoustine is a Scala library for LSP, and Langoustine Tracer is like a general purpose LSP testing, LSP like investigation tool. I'm going to have a screenshot next. If everything else fails, you're free to use print-line debugging, but I encourage you to use this as a last effort. So yeah, again, debugging is awesome, and for example, the JVM has really good debugger tools, like IntelliJ has a great debugger, and VS Code has a decent one, like in Metals, but it's getting better. So whatever tool you use, whatever language you use, it probably has a debugger, and you should probably use it. And this is Langoustine. This is like a more structured view of the payloads in the LSP, but you can also see like JSON. It's the same thing, you can easily switch. And this gives you like a layer on top of your server. You can launch the Langoustine Tracer together with your server. It will capture all the input and output of the server and show you like this history of requests and responses from the server to the client and from the client to the server. I think the server to client is actually not implemented yet, but that's just a matter of time. This is the last one, just the last slides. One issue for me personally was library choice, because I'm a Scala developer most of the time, and the standard implementations for LSP are from Microsoft are in Node.js. So on the JVM, I couldn't really use that. We already talked about why. And for Java, there is LSP4j, but it has some, I don't want to say flaws, but things that are not idiomatic in the Scala world. And until recently, there was no good library for Scala. There are libraries for other languages. But now we have Langoustine. It's a cross-platform, so it works in Scala.js, Scala native, and Scala on the JVM. It is a cross-platform library. It has a Scala first API. It's functional, no reflection, no mutability, and it even supports auto-cancellation. So if your editor cancels a request because it's like no longer waiting for completions because the user switched to something else, the server will seamlessly interrupt the call and not do any extra work. And this here is the entire example of how you would run an entire server. It does nothing, but it works. And the library is still in early stages, so just, yeah. LSP4j is still a stable choice. Here's some resources, including my link tree. All the slides, everything will be available there. So you can take a picture, you can just go to the first one, and all of this should be there in an hour or so. So this is all I have. Do we have time for questions? Okay, so we have time for questions. Any questions?
Yeah, does anyone have any questions? Okay.
Thanks. Is list of features supported by specified somewhere, or it's any server could implement any feature and expect maybe?
Okay. Yeah. So if I understand the question correctly, is there like a list of features that are in the standard?
Yeah. Yeah.
So yes, there is. On the LSP website, there's like a list of all the features, and I think like all the libraries support them. It doesn't change very often. There are like minor changes most of the time. But also, you can extend the protocol with your own features. The problem is that if you add like a new feature on the server, you also need to handle it on every client. So you need special code for every editor extension. And for example, Metals does this for like the tree view protocol. And yeah. Oh, I also want to mention there's also a debug adapter protocol, which is the same idea but for debuggers, which is really cool also, but it's not that well known.
One more question. Is this protocol support only textual information, or can it also pass information about types? And maybe on example of Scala, you can tell which exact information, how deep, how much information could it pass, a relation between types, or maybe more?
So it is text-based. So what I meant by that previously was that like if your language doesn't use text for files, for example, Unison doesn't use text as a source of truth, it may be a bit difficult to make this work, but in general it works. For the like types example, types are like a first-class feature of many of these operations in LSP. So things like go-to-type definition would be covered by this. So I hope that answered the questions. But there's nothing I know of in the protocol that would give you like I want to export the graph of types. Like that's probably too much. It's like the lowest common denominator of things that can be implemented in all these editors, or most of them at least. That's what LSP sort of is, right? Do we have any other questions?
Yeah, we have time for one last question. So I've seen the hand in the back. Oh, there you go.
Thank you. Nice talk. I'm a user of a language server, and the feature that I'm missing from editors is refactoring, renaming, extracting methods, and so on. Is there something working on language server? There is some, if you know, something going on.
I don't know of any like ongoing discussions, but rename as a special case of what you said. Rename is like a concrete feature in the LSP spec, so many servers implement that, and it just works. However, things like extracting variables, inlining, and so on, these kind of have to be implemented as code actions. So basically, when you have code and you do something like Alt-Enter, that will give you like a list. So that's sort of how things work. So compared to things like IntelliJ, the refactoring is kind of poor in LSP, but that just sort of comes with the territory. You want to support the majority of tools. But that's a really good question. Okay, I think we don't have any more time for questions, so thank you for coming, and I hope you really liked the talk.